Let's continue with the second half of what we'll cover today. I think we've probably done more than half in terms of our material we'll discuss, but back here on the course webpage, we've already seen the motivation for the course in lesson one, and now I'm here at the lesson overview. And each of the lessons will have this kind of lesson overview page as a sort of just general picture of what we're going to talk about in each one of the different lessons. It'll normally include some learning goals. So, for instance, today, you should hopefully know what kind of tools we're going to use during the course. You'll have already seen the information about like the basics of a computer and program and blah, 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 like we just saw. But you'll also understand a little bit about Python stuff, like how to define and use variables, what the idea of a data type is, and how to check what the type of a variable is in Python. This will also be the place where lesson videos will go. So there is, those will be posted after the class session normally. There's one here today from this good coding practice, because this is a pre-recorded thing from a couple of years ago. We'll leave this one here as it is, but then I'll post today's lesson videos, most likely sometime in the next 24 hours or so. Usually takes me a little bit of time to do some light editing and to get things uploaded and everything working. But those should then show up on the course page, and I usually will inform you when that's been posted. But our next thing to talk about is our course environment. And this will be the first step into the kind of computing environment that we use. It might seem a little bit intimidating at first because there's a number of different pieces of what we use that are here, but fear not, it's not going to be too bad, I hope. But this is our first introduction. Then we'll get some practice using the course environment tools, and I think by a week or two into the course, you'll have a pretty good sense of how things are working and what to use for different parts of the course. So here we have a list of the different things we're going to use. I guess the Zoom link I forgot to delete, so I will remove that. That was from the last time we taught the course when we were using Zoom, because it was all remote teaching. So you can ignore that one. But the 6 things that are here. So we have these interactive code cells that will allow you to interact with certain elements of the course webpage. I'll show how that works in just a moment. Then we have this Jupyter Lab system, which is basically the Python environment that we're going to be working in, where we actually do our coding. It's in a kind of interactive programming environment. Was there a question?
No.
Okay. I can, if you say anything, it's quite hard for me to hear it. So I guess you'll have to speak loudly if there's a question. But yeah, we'll use Jupyter Lab. You'll get some experience with that already this week just to see what it looks like. But it's a programming environment built around a document called the Jupyter Notebook that brings together both code and documentation in the same document. So you'll see what those look like in a little bit. Then we have a cloud computing environment, which is basically our way of being able to avoid having you need to install Python on your own computer, which means that basically you can complete the course just using web accessible things like the cloud computing environment and a web browser. And then we'll talk about a little bit about Git and GitHub, which is the way of tracking changes to the programs that you create. And then the voting and polling we've already been using a little bit. And then finally, we can talk a little bit about Slack. So yeah, the interactive coding cells, if we go to someplace on one of the pages of the course where there is a kind of interactive coding possibility, like for instance here, the Taste of Python lesson, if you click on that, you don't need to do that now, but you can if you'd like. You'll see this little rocket ship up at the top, and you can click the button to live code. And then if you scroll down, what you'll see is that there will be cells like this, where there's some information like here. This is basically a place where there's some code that is inside the web page, and you can click the button run, and it takes just a moment for it to launch. but this will then execute the program code that is inside this little cell here. So 1 plus 1, we're expecting once this runs to see the output be the number 2. Normally it takes, maybe 30 seconds or so for it to start, but we'll see. It might be a little bit slower just because, of course, whenever I want to demonstrate this, it always takes longer than it normally does. So, okay, we can sort of sit here and wait. The key thing is that these code cells, once you've clicked that button, become something that are editable on the course page, which is kind of cool because it means basically you can go through and modify things as you like on the course page if you want to explore a little bit more about how something works. If you said instead of 5 times 7, you want to do 63 divided by 7, you could do something like that, and you would then be able to run the cell and it will execute the code that's inside there. I wonder if maybe I've updated something here that's making this have to recreate its the thing that's used for the kernel here, which could explain maybe why this is taking a little bit longer than normal. But this should normally launch within something like 30 seconds, and then you would be able to go through and basically any place where there's some program or some code in the course page, you'd be able to run those cells and edit the cells to be able to execute the code if you would like. So that's a very quick way just to see how things are working. Maybe we can come back there and check and see how it's doing in just a moment. Actually, probably now that I navigated away from it, it won't work. But anyway, you can do that if you like. It's not really typical, but it's there as a possibility. It's somewhat experimental, so it may not always work, but it's a quick way if you want to test something on the course page. Jupyter Lab is, as I mentioned, it's a web application that's used for doing data science, and it's built around the idea of a Jupyter notebook, which has this file extension .ipynb, or IPython notebook, which is the original name of what these notebooks were called. And the nice thing about them is that they combine the possibility to have parts of your document where you have program code that you've written, and then parts where you have sort of descriptive text that could even include having figures or tables and things like that inside the same file. So you can have quite nicely detailed instructions for how to do something, and then some code where you actually do the processing, and then it might produce a plot that would be visible inside the notebook. And this is our default programming environment for the course. So we'll get familiar with this as we get started even in today's lesson. But this is an example of what a Jupyter Lab looks like, and it'll make more sense once we get into the Taste of Python lesson. I'll show you a bit how these notebooks are working. Yeah, I think there's no need to go into the details about that now because we'll get some hands-on experience in just a moment. One of the other things we can use here are the cloud computing environments. And so again, for us in this case, there are 2 options. So we have a cloud computing environment called Binder, which basically will open up a Jupyter notebook from using the course materials and allow you to then interact with the notebook and make changes to it and whatever. We have that environment, and then we have this thing called the CSC notebooks, which is offered by the Finnish IT Center for Science. This, at the moment, we're having a bit of trouble with the CSC notebooks, probably because of a mistake on my end, but I don't seem to be able to get it working properly. So we're going to be using Binder for today. We won't talk about the CSC notebooks in any detail because it's currently not functional, but hopefully by next week that problem is fixed, and then we can talk a little bit about the CSC notebooks, because this is something that's available to all students at Finnish universities, and is a nice environment to be able to work with the course materials. We'll go into details about how that works, I think, next week. But Binder's a free service that can be used to open a Jupyter notebook from many different places online where you can store them. So if we go, for instance, here to our Taste of Python lesson, you'll see there's a button here for launching Binder. I think you can also click the Binder button up here if you want to, but if you launch this version of it, it will open up a version of the notebook without any of these cells filled in for you. So that's probably what you're going to want to work with during the lesson. So like if we click the button here to launch Binder, what we should see is that this thing starts spinning, and we can kind of see what's going on here. Okay, I see red text, which worries me a little bit. But this should hopefully go through the process of opening up our notebook. It looks like it's going to have to create create our environment the first time, which is a bit slow the first time you launch it, but it should be faster to open up for any of you after I've opened this up one time. Binder is a free service, so the thing that you're stuck with Binder is two limitations. One is that it does not store any of your information. So if you're working with something, you need to make sure you download and save a copy of the files you're working with. And because once you open a Binder session every time, it's kind of like a disposable computing environment in a way. And the other thing is that you have about 10 minutes. Okay, so this isn't working. No, that's not great. Of course. I swear I tested it this morning and it was fine. So now I'm a little bit concerned about why it doesn't want to work. Couldn't find a version. Okay, so all right, I might be able to deal with this problem and get us back up and running. But yeah, normally Binder would open up whatever we're working with, and then it would be no problem to interact with our notebook materials. But yeah, the drawback doesn't save any of your data. So any changes you make to your notebook, you have to download and save yourself. And the other thing is that it has about a 10-minute time period of inactivity. So if you don't touch the keyboard or do something in the notebook within about 10 minutes, it will disconnect. And then it's sometimes able to recover, but most of the time you kind of are stuck at that point. So the reason for us using the CSC notebooks in the future will be that it has a way to save our data in the system, so that like every time you sort of open it up, you can carry on from where you left off, which is the big benefit over Binder. Okay, I will have to sort of see if I can figure out a solution to this issue, but we'll go there. I would like to have demonstrated how Binder works, but of course, it's not working properly. As noted, the CSC notebooks we won't introduce right now, just because it's not functioning properly at the moment, and the instructions that are here relate to the old CSC notebook system, which doesn't apply anymore. So nothing here will actually work for you if you try to follow these instructions. We'll update that hopefully later this week, and then we'll be able to use that from next week and moving forward from there. And of course, you can install things on your own computer if you like, as well. Now, for Git and GitHub, these are basically, Git is a way of tracking changes to your programs. So it's what's called version control software. So when you're working on your exercises in the course, we're going to be using Git. We're going to be using GitHub. And this is a way for us to basically make sure that you learn the practice of storing the changes you make to your programs regularly, so that if you break something, you can go back to an earlier state and you don't get stuck in a situation where you can't remember what you changed and now your code doesn't work and it's like 10 minutes before the deadline for the exercise and you're freaking out. So we will introduce Git and GitHub in more detail next week, but Git itself is software that was developed by Linus Torvalds, whose auditorium I believe you're sitting in the Exactum at the moment. Also the creator of Linux, so rather famous Finnish computer scientist. And yeah, the basic idea is that you have this thing called a repository, which is where all your files are stored, and then Git is able to track changes to any of the files inside the repository that you might consider a repository to be something like a project. And the files that are in there, you can basically have ways to record the changes that you make. You do this manually yourself, so it's not kind of automatic, but you basically would regularly type in some certain commands to store the changes that have been made to the files that you're working with in your exercises, for example. Now, GitHub is a web page that's essentially a way to interact with Git repositories. So it hosts software that's stored in Git repositories, and it's also got some kind of social network features that allow people to share code, to interact with one another's code, and to collaborate on developing software using the GitHub webpage. You'll get some experience with GitHub already this week in the exercise for today. But we'll leave it here for right now because you don't need to go into great detail. We'll talk about Git and GitHub in more detail next week. We've already seen the voting and polling, so we don't need to talk about that too much. The webpage link is here, and you'll see that during class. We can use that. And whoops, this should be Geo-Python 2022. But yeah, about this application called Slack, we can maybe actually jump over here to see some information about communicating with Slack. And you should all have received an email from me this morning with an invite to join the Slack organization for Geo-Python 2022. So we have a Slack team, I guess is what they call it, called Geo-Python 2022. And once you accept the invitation, you can go to this page here to access our Slack. Well, what is Slack? It's basically a way in which we can communicate in a sort of chat type application. So in some ways, I guess it's kind of like WhatsApp, but the difference is that the discussions can be grouped into separate channels and separate topics to help kind of keep the discussion organized. And there's a good search functionality. You can notify users using the @ character, and then you can also have threads, which are ways to have a conversation in which that from a single chat you can then have a thread of conversation that stems from there. And this works nicely on a phone or browser, iPad, whatever. So this is what the Slack looks like for us here. So now this is just the Geo-Python 2022 Slack, the web version of it. So I'm here in the general channel. So you can see the channels over here on the left. And so I could say hi @ channel, which would basically send an alert to everyone who is currently signed up in the Slack organization that I posted there. And now it warns me that I'm going to notify 30 people. And so I say, fine, that's okay. So I can say something like that if I want to call everyone's attention to something rather urgent. So occasionally, like when if we post an updated lesson video, then oftentimes in Slack, I will put a thing where I tag the channel to let everyone know that the new lesson video is now up. I could also say hi to a specific person like Christoph. And say, hope all is well in Kumpala. And then he can see that he would get an individual notification that I had tagged him in a message, and then would be able to, for instance, respond to what I have said in some way. So there's different channels here, as you can see. So I think I can see already that Christoph is typing something in response. So and looks like everything is fine in Linus Torvalds auditorium. That's good news. I can also react to what he has said. So I can, choose a heart or whatever to express whatever feelings I have about what he's just said. Or I could respond in like a thread here You'll see when you sort of hover over someone's message that you could do things like reply in thread, in which case that I could say, let's keep chatting in this thread. And what this does is it basically just then kind of groups a bit of the discussion related to a single post into a thread where, rather than filling up the channel with a bunch of replies and whatever, that anything that's directly related to another message could go into a thread. And it's a nice way to kind of keep things a little, a little bit more organized. So you won't see necessarily all of these different threads, but you should see most of them. Those of you who are students in the course won't see the instructors or the CSC hotline channels because those are used for the teachers. But otherwise, you should see all of these, including like the different weekly channels. So if you have questions about specific week's exercises, you can always post them in the week 1 channel or week 2 channel, whatever it might be. If you have general things, you can always post them in general. I think there is also a random channel where if you just want to post some silly things, you can do that in there. And those who are having problems with enrollment are welcome to go into the enrollment issues channel and post there so we can help making sure you get enrolled properly to the course. I think that's kind of a quick overview of how things work in Slack. I think it's a fairly intuitive interface to use, but let's just take a look at the course page for a second. Excuse me. So yeah, just as a sort of reminder, all the channels are listed here on the left side, so you can see the different channels there. The one that you select is the one that you would be then posting in when you start typing. As noted, you can use the @ symbol and a username to get a specific user's attention. And then I showed an example also of how to create a thread, which is a handy thing to do to keep the discussion kind of organized. And then, yeah, otherwise, I mean, there's some general guidelines here. This is basically, I've said this already. Like if you have a question related to week 2, you should post in the week 2 channel. You can use threads to kind of keep things clean. If something is confusing, please don't hesitate to ask in Slack. This is a useful place for us to have the discussion because it's kind of out in the open. So if someone asks, it's usually not that you're the only one with a question about something in an exercise or a lesson topic. So it helps the other people to also see your questions. And in fact, oftentimes some of the other students may even respond to answer the questions if they're able to do it before one of the instructors is able to help. So that's a great thing to do. Please do use Slack for asking your questions. And also, you're more than welcome to discuss and comment on things that you see in Slack and help out one another and things like that. The only restriction we say is please don't provide kind of like ready copy-paste answers for the different parts of the exercises, because obviously that's not really in line with your learning the Python programming language. So there is some limitation there to the Slack usage. But I think you'll probably find it not too hard to pick up and figure out how Slack is working, and you'll see you'll get some experience using it already for this week's exercise, so that's not a bad thing. Okay, so now our Taste of Python lesson was not cooperating and launching properly, so we may have a little bit of a challenge here to get this to work. I'd like to get this.
I think I fixed the notebook in the background in the meantime.
Ah, okay. Did you fix the build requirements?
Yeah, I just removed the version tags from the requirements. That was the problem.
Okay. So let me see then if let's see if we try it again now. Because I think it's possible. Okay. Very good. So thanks, Christoph, for fixing that, which means that if this is working for me, it should also be the case that all of you can go to this part of the Geo-Python lesson. So if you go here to A Taste of Python on the course page under Lesson 1, you can click the red Launch Binder button at this point. And we'll get our first little opportunity to do some interactive coding in Python. So yeah, please go and do that. And if there's any problems, maybe Christoph, you can let me know. But it should be okay, I think, and this should hopefully launch for everyone. I'm just going to make this a little bit bigger and then click on the file browser button over here just to hide that so we can see the notebook here. But this is a Jupyter notebook, and it has both in here our instructions for what to do and some places where we can type things in. And as noted, this is an interactive document. So when you put something into a code cell, the way to actually get the code to execute is to press the Shift key and then Enter, which we'll try out in just a second with some examples below. And I think there's no need to worry about this part here about opening Jupyter Lab, because I think everyone should hopefully be running in Binder. It's not essential that you follow this part in Binder, but it might be fun and kind of handy to do so, because that's essentially the way that we've designed the course to work. So I hope most everyone was able to get their Types to Python notebook to open up. If not, you can always close it and try to relaunch Binder again if it's giving you an error message or something like that. But normally it should work. And so for us then, it means that if we look in the first section here of our lesson, it's about variables, math, and functions. And this is basically just going to be a quick introduction to doing some things in Python. So as you can imagine, you can use Python for some simple math like 1 + 1, not a problem. So I type in 1 + 1 and I press Shift Enter. When I run this, you can see that my calculation that was done here returns a value of 2, which is more or less what we would expect. Or exactly what we would expect, I suppose. Likewise, I can do multiplication. So 5 times 7, I can do like that. I could press Shift Enter if you prefer. If you're kind of a mouse-oriented person, you can also go up to the top here and click the play button. That will do the same thing as pressing Shift Enter. I'm a kind of keyboard-oriented person, so I tend more to do things with the Shift Enter key combination since I'm already typing in the cell. But what you can see basically is that when you select a cell by clicking on it, it is editable, and so we could change things in here whatever way we would like, 2 + 5 if we wanted to. And again, if you press Shift and Enter, it then executes the code that's inside the cell and returns the value from the executed code. That's the sort of basics about how these different cells, the code cells, are working inside of one of these notebooks. And if you want to edit it and rerun it, it's no problem. You just change what you want and then again press Shift Enter, and you'll get your new calculation returned when the contents of this are run and evaluated by a Python interpreter. So simple math is no problem. 1 + 1, 5 times 7, no big deal. We can also use Python for more advanced things by using some functions in there. So a function is just a piece of code that performs a single action. So something like printing information to the screen, calculating the sign of some number. And there's a huge number of functions that exist for different things in Python. So you could take something like sine of 3 and type that in here. And although you might think that would work, there is an issue here, and it says sin is not defined. And if you took something else like a square root of 4, you should expect to get a value of 2 back, and it says, well, no, square root's not defined. And this might concern you to think that Python can't do this kind of basic like trigonometry or sort of things like a square root. But of course it can. The thing is that the default math that's available to Python is really stripped down. So what it can do by default in terms of math is add, subtract, multiply, divide, or raise something to an exponent. That's more or less it. So the default options are somewhat limited for what you can do with with math. If you want to do, 2 to the power of 3, that's no problem. It's double star. But if you want to do a square root, if you want to take a sine or cosine, you have to use a library or a module for doing that. And in this case, the basic math library in Python is called math. And the way that we make it usable for us is by typing in import and then the name of the library we want to use, which is called math. Now, the math library is built into Python, but it's just not enabled by default because the idea is to make the language as sort of lean as possible when you first launch it, rather than sort of giving you all the possibilities and many things you wouldn't use. The perspective is that it just launches with very limited capabilities, and you are then responsible to tell it what you need to add to be able to use things like other math calculations. So if I run this with Shift Enter, the import math should very quickly be executed. It doesn't return any values, but now if I wanted to calculate the sine of 3, I would type math.sine of 3. So I would give the name of the library and then dot, and then the function I want to use, which is the sine function, and then inside the parentheses would be the value that I want to calculate. Now, in this case, when I run it, instead of getting that error message back that we saw before saying that sine was undefined, it now says, oh, you want me to use the sine function from the math library? No problem. Here's the value, 0.14112, blah, blah, blah. So same thing goes for the square root, that we can do math.sqrt of 4. No problem. Shift Enter to run that one, and I get math.square root of 4 is equal to 2.0, which is what we expect. So it's not that these math functions aren't available to us, like we tried to use them earlier. It's just that what we need to do is we need to bring in the math library to be able to do those kind of math functions. So we've been able to import this using an import statement. I'll import and then the name of the library you want to use, and then to use functions that are part of that library, you type the library name, a dot, and then the name of some function that you want to use from that library, such as the sine or cosine. We could easily make this instead of math.sine, math.cos. And if I run that, of course, I get a different value, but it's not a problem to use the cosine function. And we could also do math.whatever log of some value. So, I mean, there's many different functions in the math library that we could use. And yeah, I think that's the kind of basic idea about the sort of libraries. You can see a little bit more detailed instruction here, but essentially the sort of concept of a module or a library is that it's a group of related functions and things. So in the math library, we have a bunch of functions that relate to doing mathematical calculations. And once we've imported it, we're able to use the different functions with the name of the library and then dot the function name. And in addition, there are things like some constants and values that are called attributes that can be part of a library as well. So if we take, for instance, the math library, we could look at the value of math.pi and just run this. It's not a function. It's just there's a value called pi that's part of the math library. And if you run this cell, then you get 3.141592, blah, 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 the first, 16 digits of pi or something like that. And so there are also values that are kind of constants that can be related to a library that are also available to us to be able to use, which is handy because then you don't have to worry about hand typing in the value of pi every time you want to use it, but you can use the math.pi to get that value. So now you have a chance to check and see how you've understood things so far. So you can use the empty code cell here below, and you can type in your solution for how you would calculate the sine of pi. And then you can also maybe think about what value you would expect to get for this calculation, and then whether or not you got the expected result. So why don't you take a minute to do that, and then maybe Christoph can let me know when it seems like most people have made their attempt, and we can continue from there. All right, very good. So yeah, our task here was to basically take a look at how we would calculate the sine of pi. Now, you might recall that we could get the sine of some number, some value, by doing math.sine, and then inside the parentheses, we could then put in the value we want to calculate. And in this case, it's perfectly fine for us to put in math.pi inside the brackets here, because remember that math.pi simply represents a number that is equal to the value of pi in the way it's defined in the math library. And so to calculate the sine of pi, we can simply do math.sine and then parentheses math.pi. And if you remember from maybe high school math, you would hopefully note that the sine of pi should be a value that is very close to or exactly equal to 0. And in this case, what we end up with when we calculate the sine of pi in our estimation here, or calculation in Python, is that we get 1.22 blah, blah, blah times 10 to the minus 16. So it's a number that's not exactly equal to 0, but very, very close to 0. And the difference between this number and 0, of course, is very small. But this representation of pi in the memory of the computer is probably truncated after a certain number of digits, which means that when you calculate the sine of that value, you don't get exactly 0, but sorry, number that's very close to the value of pi. And so as a result, you're close, but not exactly 0 for what you get back. So saw an example here of how to combine what's called a parameter value, an attribute value, which is math.pi. Pi would be an attribute of the math library, and it's a number in this case. But we can also combine functions. So if we wanted to, for instance, print out some kind of value using the print function, we could use our print function, which is simply print. And then inside there, we could do something like math.sqrt for the square root. And let's maybe do 81 just to get a little bit different value. We need to make sure our parentheses are all matched. So our square root function should have an open parentheses and a closed parentheses. Our print function should have an open and close. And if that's all okay, then we can run this code where we've combined here the print function with the square root function, and we get back a value of 9, which is exactly what we would expect. Again, we can make this maybe a little bit more interesting by combining some text with our calculation here, because otherwise we don't really need to use the print function to do this at all. But we could say, for instance, print, and then here, the square root of, let's say, 49 is, maybe I'll note a couple things here. So in this case, because I'm adding some text there, I have to put my text in quotation marks. So it doesn't matter whether you use double or single quotation marks. Double quotation marks seem to be preferred in Python, just from a sort of aesthetics perspective. It doesn't actually function any differently than a single quotation mark. But you'd have, yeah, the square root of 49 is enclosed in some quotation marks and then a comma. And then here we would do our math.sqrt of 49. And then again, make sure our parentheses are balanced. So this should print out the text. The square root of 49 this is what's called a character string. So it will print out exactly these characters. It's not going to try and treat them like variable values or anything like that. And then after printing that out, it will then print out the value of the square root of 49. So if we run this cell, you'll see that the square root of 49 is 7.0, as we would expect. So it's relatively easy in a way to combine multiple functions, and particularly like printing things out while you have some text in a function is a very common thing to do in a Python program. And of course, that's not something that's too difficult for us to do here either. One thing we haven't dealt with yet are variables. And a variable is basically just a name or a sort of, well, I guess it's basically a name of something that can be used to store a value that's calculated from some kind of mathematical expression. So we can assign a value that would be calculated to be stored as a variable name simply by typing the name of the variable equals whatever the value is that we want to store. And so, for instance, here we could say define a variable called temp underscore Celsius and give it a value of 10.0. So we could say temp underscore Celsius equals 10.0. And so that allows us to define a variable that is called temp Celsius that has a value equal to 10. On the line underneath that, so I'm not going to press Shift Enter, but just Enter here, which will give me another blank line in the cell. I could then print out temp underscore Celsius using the print function. So there's our print function, and inside here we have our variable name temp Celsius. So when we run this, what we see is that first, temp Celsius is stored in a variable, or the value of 10 is stored in a variable called temp Celsius, and then that value is printed out to the screen. And so, we could even go a little bit more in the direction of what I was trying to do in my earlier attempt with the demonstration for how to create a program, and that is that we could make a little simple temperature converter and print out what our temperature in Fahrenheit would be for an input value of temp Celsius. So here we have temp Celsius equal to 10, and we could maybe print out, in this case, again, I'll put a quotation or double quotes here, temperature in Fahrenheit, which you could just put as F if you want. But it's kind of a clumsy word. Again, close it with a double quotes and then comma. And then here I'll convert temp Celsius to a temperature in Fahrenheit by multiplying by 9/5 and then adding 32 because that's our temperature conversion. So 9 divided by 5 times temp underscore Celsius. So yeah, 9/5 we just convert as 9/5 times temp Celsius and then plus 32 will give us our temperature in Fahrenheit. So our temperature of 10 degrees Celsius, if we execute this cell, we'll find out what 10 degrees Celsius is in Fahrenheit. And in this case, it comes back saying temp in Fahrenheit 50. So there we're able to now combine some string of text with calculation that's done using a value in a variable. So after the comma here, basically everything that is that's done here will then be shown as the next thing in the print statement. So if you have comma separated values in a print statement, it will just kind of print them out sequentially. So it prints temperature in Fahrenheit first, and then prints out the result of this calculation here, where it takes whatever, I guess it would be basically 9/5 times 10, so 90 divided by 5 plus 32, which indeed is going to be 50. All right, so then why don't we continue to our next opportunity for you to check your understanding. So in the Python code that's, or Python cell that's empty below here, you can now define a variable, print its value to the screen using the print function, and basically you're free to do whatever you like in terms of how you want to name your variable and print it out to the screen. It's sort of, you're free to choose, and then we'll have a look at my example after that. One thing I would say that you're welcome to try and use if you want is what's called this pothole case naming. So this is basically where you have words in the variable name separated by the underscore character. It's a very readable way to write your variable names. So you could consider, for instance, using that type of variable style for your variable name if you'd like. But yeah, take a minute and make yourself a little example where you print out, define a variable and print something to the screen, and then we'll continue in just a moment. So yeah, let's just look at a fun example here. So one thing we could do, for instance, is have a variable called part1, which we could say is equal to I like. Part2 is equal to Python. And then we could print part1 and part2 like this. And we should expect to see I like Python as the output here, because it, again, prints this string of characters here first, and then with a space in between, then prints the second string like that. So there's, of course, an infinite number of possible solutions for this example in this case. All right, let's have a couple other things that we can take a look at here, updating variables being one of them. So we just had assigned the value of 10 to the variable temp Celsius earlier. It's, of course, possible to assign a different value to that same variable, like 15.0. So basically just say the same thing we did before, temp Celsius equals 15.0 instead of 10.0. And if I run that cell, it doesn't return any output because we just assigned a value to a variable. But then if I was to print out something like temperature in Celsius is now, and then, oops, temp underscore Celsius, I would get the output with this character string temperature in Celsius is now first, and then the value of temp Celsius, which has now been changed from 10 to 15. No surprise there. If I was to try to do something here like do our temperature conversion in the other way. So we had temperature in Fahrenheit we converted before. We could do the opposite direction, say temperature in Celsius, where we would say instead of 9/5, 5 divided by 9 times temp Fahrenheit. Minus 32, and I need to have some parentheses at least around this thing. So this might seem like this is going the opposite direction for the temperature conversion from Fahrenheit to Celsius. Of course, if I run this, I get a name error. And the reason is because I haven't defined a variable called temp Fahrenheit yet. So in order to be able to use a variable that is with some name, it has to be defined and stored in memory in the notebook first. So like I could use temp Celsius in here, but of course what I'm trying to do is convert from Fahrenheit to Celsius. So instead, what I would need to do first is to perhaps define a value of our temperature in Fahrenheit. So I could just scroll down here below and say, for instance, now temp Fahrenheit. And note that I'm using another style of variable formatting here. So this is called Camel Case, where you use a capital letter to indicate a new word in your variable name. I think Pothole Case is probably still kind of preferred, but this is just another style in case you're curious. So temp Fahrenheit equals, and we'll do it like this. We'll say 9 divided by 5 times temp Celsius plus 32. So we'll just take our temperature, temp Celsius, convert it like that, and store the resulting value as temp Fahrenheit. So if I run that, I don't get any output again because I've assigned the value here. But actually, if I go back up to where I had printed out my temperature in Celsius before and run that cell again, now I've defined the value of temp Fahrenheit. So when I run this cell by pressing Shift Enter, now it works. So now I get my temperature in Celsius is 15 degrees. So it's kind of a silly thing to calculate in a way to convert from Celsius to Fahrenheit and right back to Celsius, but just to demonstrate how that's working, the order in which you execute the cells can make a difference. And the reason I want to emphasize that is that when you're working on the exercises, you have to be a little bit careful that sometimes you may have executed the cells out of order in your notebook, and it might mean that you get different results. So if I hadn't run this cell first to store the value of temp Fahrenheit, then I was getting the error message when I tried to run the cell above it here. In terms of programming practices, probably best to not have these things in this order in the notebook, but rather to always define temp Fahrenheit above the point where you try to first access it, rather than assuming that the user would run a cell lower down and then come back up to run an earlier cell. But you can do that, and it's possible, and it actually can cause trouble sometimes if you've done things out of order when you've been testing things in your notebook for your exercise. That sometimes you can get unexpected results that way. And yeah, I think we could probably also maybe just give an example here of if we printed out temp in, I'm just going to call this temperature in C to make it short, and that's temp Celsius, and temperature in F is temp Fahrenheit. So a little bit longer print statement here, but basically all it's going to do is print out our value of the temp Celsius variable and the value of our temp Fahrenheit variable. So when I run that, I get temp in C is 15 and temp in F is 59 degrees, which sounds roughly about right for what I would expect. Yeah, I mean, I suppose the one other thing here that we could show is that if you change the value of temp Celsius, it does not change the value in temp Fahrenheit. So even though we converted the value of temp Fahrenheit using the value of temp Celsius, it's only when you run this code cell that you update the value of temp Fahrenheit. So this is a little bit longer example from the course page. So I'm just going to copy paste this because I'd like to get to some other things before we run out of time. So don't worry about typing this one in. But the point is, if we redefine temp Celsius to be equal to 20, it says temp in Celsius is now temp Celsius and temperature in Fahrenheit is still 59. So we see that updating one doesn't necessarily update the other one. So it's not quite like an Excel spreadsheet or something like that. Okay, maybe one other concept to introduce. I don't think we'll get quite through. Well, I think we'll get the basic idea here of what the data types are. I think we'll skip our last check your understanding. You can maybe do that on your own if you'd like. But yeah, when we define variables, and actually for the values themselves, each one of them has a sort of its own data type that is used to represent sort of what you can do with that value. So there's 4 kind of common data types in Python. So there's integers, which are whole numbers. So like the value is 4 with no decimal point. There's floats, which are decimal numbers. So 3.1415. First, 5 digits of pi. STRs for character strings, so that would be text in quotation marks, and then bool, which is for true and false values. And we can determine the type of a value or a variable using the type function. So if we define a variable, for instance, called weather forecast, we could say it's equal to hot. I don't know. I haven't been outside in a couple of days, so it's probably not hot, but we could define that, and then we could basically check and see what is its data type by typing the function name type and then the variable weather forecast. So if I run this, again, the assignment here of the value to the variable won't return anything, but type function should return a value to the screen. And we see here that the type is str for a character string, which is expected because we have a value assigned in quotation marks. So we could also, check other things if we wanted to. We could say, maybe I'll just add a cell here. So just in case you're curious, it is possible to add code cells by just clicking the plus button up here. So we could add another code cell here. If you want to check, for instance, the type of the number 4, we expect that to be an integer, and indeed it is. And if I put in 4.0, then I get this variable back as a floating point number. So the presence of the decimal point matters. And the same thing goes that if I check for the type of the value that's true with a capital T, then it comes back as a bool, same way that false with a capital F would come back as a Boolean, meaning it's a true and false type of variable. So I could assign those, to be some variable first and then check their data type. But the point with this in general is that there are some variable types that are compatible and some that are not, for doing things like mathematical operations. So you can imagine that integers, whole numbers, and floating point numbers are pretty much compatible with one another. No problem to add them together, divide, multiply, whatever. But the same is not necessarily true for things like a character string. So if we took the example equation here, I'm just going to copy it in the interest of time. And just copied this and pasted this in here. So temp Fahrenheit equals temp Fahrenheit plus 5 times weather forecast. So as you might remember, temp Fahrenheit was a number, floating point number. Weather forecast is a character string. So now we're like, okay, computer, let's multiply this character string by some numbers and add it to a number. And of course, the computer says, I'm not really sure how to do that because these data types aren't compatible. It's not clear what you want me to do when you say add a number to some text. Like, is it supposed to be the number as text and then the rest of the text, or is the text supposed to be converted to a number and then they're added together? So here you get a type error, which is telling you that the data types that you're trying to use are not compatible. It's not to say you can't do any math with a character string. Like, it's not a problem to do 5 times weather forecast. Again, I just added a code cell here with the plus button. What you do is you get that same character string repeated 5 times. So hot, 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 hot. If you want to do it 50 times, no problem. Python's quite happy. I don't know how far you want to push it, but you can multiply things without a problem. But if you start trying to subtract this character string from numbers or add it to numbers, then that's where there can be some confusion. Here, we're just basically saying, repeat this a certain number of times, which is not a problem to do. Okay, so we have a few minutes left here. And I would like to maybe take a quick look at the first exercise, but are there any questions at this point? I'm sorry it's a little awkward to address them on Zoom like this, but are there any questions? Probably.
There's no questions, or everybody's very shy.
Yeah, I think probably everybody's in the same boat as I am of wanting to get this over with and be done with today's class. So let's have a quick look at the exercise for today so you know what to do for this week's exercise. So back on the course page, exercise number 1, you'll find here at the end of lesson 1 materials. Exercises are due a week from when they're assigned. So by the start of the next class, you should have the exercise 1 submitted. And exercise 1 in this case comprises 3 things. One is to go to github.com and create an account for yourself. So you can go to the GitHub webpage and you'll find the button to sign up there. You'll make a username and fill in some information there to create your GitHub user account. That's the first thing that you'll need to do. That's a pretty straightforward one. Part 2 is also fairly straightforward, and that is to make sure that, is this, I thought I had updated this. Okay, this was cached. To make sure that you go to the Slack, our Geo-Python 2022 Slack, go into the week 1 channel and make a post there with your full name, your GitHub username, and the course code that you are signed up for. And if you're signed up for something other than one of the codes in the University of Helsinki, then you can also put something else there. But this will help us with keeping track of who all the users are and linking them to their GitHub usernames, because some of you get quite creative with your GitHub usernames, and it's not as boring as like Christoph and myself, where it's like Dave Whip, and then Dave Whip, and Christoph Fink, and Christoph Fink. Some of you go for rather creative things, which doesn't make it so easy to tie the GitHub username to who you are. So it helps us if you post in Slack once you've created your GitHub username. So that's your second task. And then the third one is to actually cook up some Python yourself. And to do that, once you've created your GitHub account, you'll be able to click this link to create a copy of the exercise for this week that you'll be able to update. And you'll be able to add your modifications to the exercise and then save that in GitHub so that we can then see that you were able to create the assignment and complete it as as planned. We can go here quickly and have a look at what the coding part of the exercise entails. So let's just make this again a little bit bigger. So a couple things. One is that we do have a pre-course survey that's handy for you to fill in. So when you start the exercise, if you can go and just put in some basic info here to the Elomake e-form thing, then we'll be able to see how much coding experience different people have, which will help us in pairing people up for some of the later exercises. So you could do that. But then otherwise, we've got this exercise built around the idea of Finland being the world's happiest country once again. And this is based on some kind of nice like quantitative assessment. And we're going to try and just strip everything down to 2 of the most important happiness factors in life, which are ice cream and sleep. So your exercise will be to fill in some information about how much you like ice cream and how much you like sleeping. And then from that, create your solutions. So you'll make your own Jupyter notebook to start, and you'll see how to open Jupyter Lab from the landing page for the exercise number 1. And you'll define a couple variables called ice cream rating and sleeping rating, which are numbers between 0 and 10. And then you can use this input function, which I think is covered at the end of the lesson. So we didn't quite get to it. Do I have that open here somewhere? I think it's actually here. This character input thing, you can read a little bit here. It's quite, I think, intuitive to see how it works. But you can use the input function to be able to input your first and last name. And then you'll do a little bit of math here, which is where you average your ice cream and sleeping ratings into a variable called happiness rating. You'll check your data types, and then finally print some text out to the screen that reads something like this. So here's my example where I gave eating ice cream a score of 9 out of 10. Sleeping enjoyment is 8 out of 10. Probably right now I would say my body feels like it's a 10 out of 10 because I'm pretty much tired all the time. But based on the factors above, my average, of course, is 8.5 out of 10, or 85% sleeping enjoyment, or sorry, happiness rating rather. So that's your task in the first exercise. It's basically to create a Jupyter notebook with a few cells in it to do these different tasks. And you will have the opportunity to get some guidance from the course assistants on Thursday and Friday in the exercise sessions. Both of those take place in the GIS classroom in the physicum. So I think it's A113, A114 in the physicum's A corridor. And so if you're having any issues with things, please feel free to go to that classroom on Thursday or Friday during the designated times, and you should be able to get some help. Beyond that, I think just keep an eye out in Slack for when the lesson video is posted, and for when, if we've resolved this problem with the CSC notebooks, I may just post there, because I'll probably update the course webpage. If you'd like to try using the CSC notebooks once it's available, you can test it out. But we'll go through this again next week, because I think it's probably going to be where most people are wanting to work in general. So any questions about exercise number 1?
No.
Okay. So yeah, hopefully I will be able to join you all in person next week. Let's see. And it'll be a little bit easier for me to then gauge what your body language and sort of fatigue levels are like, because I'm guessing you're probably getting a bit worn out by this part of the lesson. But yeah, if there's questions, let us know in Slack, and otherwise we will catch you in the exercise help sessions or next week back in the same classroom at the same time. So see you all next week.